Alright, so welcome back. My name is Jesse and in this wonderful and exciting tutorial, we're trying to explore a new concept that was introduced by Google called A2A Protocol. So A2A stands for Agent-to-Agent Protocol and it's totally different from an MCP protocol. So as you already know, MCP stands for Model Context Protocol, which is a standard or an agreed upon contract that allows us to connect LLMs to tools, resource, and prompts. So let's say you have your client here. So the client is just an MCP client. It can be an IDE. It can be just an LLM IDE that talks to an LLM, or just a wrapper around an IDE, wrapper around an LLM, right? Agent. It can be an agent. And then we need to improve the context of this LLM or agent, right? So how do we do that? So that is where we use MCP, right? So we just have an agreed upon standard to allow us to connect our LLM to tools, resource, and prompt. Right, and we use it through the client-server architecture via an MCP protocol. This is good, but we now have standardized how we connect to tools, resource, and then prompt. But in a more complicated system, let's say you have two agents. So we have one agent here, so agent 1, and then we have another agent 2. Right, so these two agents connect to their tools, resource, and prompt through the MCP protocol. But initially there is no standard between how these agents connect to one another, right? So that is where we have the A2A protocol. So an agent simply is autonomous entities, just simple LLMs that perform complex tasks and need to communicate with one another. So just an LLM with a while loop, right? Simply like that, and that has access to tools and then can do some stuff by themselves. So we want to standardize how agent 1 and agent 2 connect to one another, how they talk to one another. That is where we introduce the A2A protocol. So A2A stands for Agent-to-Agent Protocol. It was introduced by Google, Agent-to-Agent. So it's just a simple way designed by Google to standardize how agents talk to one another. So how this agent talks to this agent and how this agent talks to this remote agent, and all of these things are now going to communicate to their tools via the responsive standardized MCP protocol. That is the main idea behind it. So it's simply just MCP is just connecting your model or your LLMs, your agents, to their tools, resource, and prompts. But agent to agent protocol is just how we standardize how agents talk to one another. That's the main idea behind it. So a use case is like, for example, like let's say you have a data analysis agent here, and this data analysis agent does takes in some data, and then it needs access to some tools, so some other tools and functions and some database right somewhere. So it needs to fetch those information, and then we need a standard way to do that. So the data analysis agent will talk to the MCP server, get the required tools and the required data, and then do some tasks. So after the data analysis agent has finished its tasks, it now needs to send all the results and then communicate the results to a data visualization agent. And what this data visualization agent do is it's now going to pick the result from here and then go talk to another MCP server, right, via MCP protocol to get some plotly tools and some functions to do some plot or to generate some report. So that's the main idea. So the individual agents will talk to their individual respective tools via an MCP protocol. But if they want to talk to one another, then they need a standard, and that standard is the A2A protocol, right? So that is how these two agents or more agents will talk to one another. This was introduced by Google and it's a very recent concept. So if I go to the official website here, so Google GitHub.io, we have the A2A protocol, which is just how we standardize how one or more agents, right, talk to one another, right, in a simple way. That is a basic understanding. So you can check the article and read about it. As you can see from here, you can see some illustrations whereby we have an agent here and another agent, and they talk to one another via an A2A protocol. And then also they talk to their respective tools via an MCP protocol. That is the basic understanding. So in case you want to read more, you can check this link here. And as you can see, this is very recent. So if you go to GitHub, you see that it just came like 2 weeks ago. So this is 19th April, and then it's 2 weeks ago that is when they made their initial commit. And you can see that it's very recent, right? So as time goes on, it's going to be improved, and then it's going to become an accepted protocol, just like MCP. Perfect. So let's see how to build a simple A2A protocol in Python. So I'll go back again to my workspace here, and then I'll go to my A2A protocol. I already have something here, so we use a simple tool. So pip install Python A2A, that is the name of the package you're installing. So you go this way, and in case you want to install everything, so we go with all, then we install everything that we need. Right, perfect. So let's come back here. I already have created some here, so I have my A2A server, right, and then we have my client. So let's open it. So I'll go back here, and then I'll open it here. Now let's see how it works. So the package we are using is called A2A, so Python A2A. So I can see that I already wrote some code just to make it simple for everybody and not to spend a lot of time. So what we are doing here is that first we can use fast MCP, right, normal MCP, or we can just simply use something like this. Right, so as you can see, I just commented out. Let me comment some out, and then we can just use what I mentioned. So this was the one I was talking about with the analysis agent. So we have a simple analysis agent here. Let me hide it, unhide it, and then let's hide this one, right? And I'll explain. Perfect. So let's start. So how does it work? So this is the basic idea behind it. So what we do is that first we have two agents that want to talk to another. So then one is a data analysis agent, one is a data visualization agent. So with the A2A Python package, which is coming from here, which is also a new package, as you can see, this is the package and it's very recent. I said also last week, right? What it does is that we just import from Python A2A, we create an A2A server, which has access to scales agent and then some run server, right? So what we do is that we create a simple class. So this is the name of the agent, some description, and then we use a decorator to decorate that particular class. And this agent has access to scales. So these scales are different from the tools, right? So this is just the scales that this agent has access to. So we have some scales, some description. Then you define your function. So this is a simple function we define just to do some analysis. Then we also have another scale that we have designed, which is one is a test analysis, one is a data analysis, one is a test analysis, right? All of these things we define one here. So these are the scales or the functions they are supposed to do. Then we have another uniform function called handle task that checks and then apply these tasks, right? Irrespective to what we have here. Perfect. And then we just return. So to run, we just go with the agent, then analysis agent, then run server, then agent. So let's run this one. Go back again. To run, this is like Flask. So I just go back to my A2A server. If I run it, you're going to see that it's going to listen on a particular port, which is like Flask. I'll copy this one here. Then let's see how it looks like. So this is how it is, right? So with the A2A Python package, we simplify the entire process, right? Of course, as time goes on, because this is quite new tools will come to make it easier. So this is the analysis agent, right? And this is the card, the agent card. So the agent card is just a way that describes how one agent will talk to another agent, right? So we have the agent information, the version, the protocol, the URL is listening to it, the available scale. So this is the scale that we defined here, which were these scales, as you can see from here. We had the individual scales that we had, right? So these tags and the scales that we defined, these are the scales here. Perfect, right? And then in case you want to view that agent, so this is how you talk one agent to another. You just go to the view agent card, and this is a standard designed by Google, which is just a JSON RPC, so that one agent will need to send to this particular agent to get information about it, right? Perfect. And then let's go back again and go to the syntax. If I go to the syntax, we have this syntax here, and that is where if one agent wants to talk to another agent, this agent will send whatever response or whatever you want to do to that send task here. Perfect. So if I go back again to the client, you can see that it's a very simple code. So what we are doing is that we are just connecting to the endpoint via the client, and then we are now sending this information to this particular endpoint, and it's going to be sent here, right, to this endpoint, and then we can get the response. So let's run this one. So I open another tab. Let's get out of here. Bin activate. Source bin activate. Then I'll move to my A2A. Then let's run my client. If I go back here and I write in the client here, so now the client is going to connect to it, and you see that it's sent. It just shows some information about it, and it's going to tell you a response, right? So the reason it did not give us any response is that I made some changes. So let's put the at here. Let's go back again. Just close it. Yeah, so I'll go back again. So I'll just put my decorator. Right, so this is how I want to send it. Let's save it and then let's run it. Yeah, again. Yeah, I'm going to run my code, and I said it's going to return some result. Right, perfect. So that is how one agent 1 and agent 2 will talk to one another. Right, it's just going to send the information to this particular endpoint via the client. Right, that is something I want to share with you. I hope you have learned something. So thank you for watching. So it's a very simple concept, a very simple but yet powerful concept that allows us to connect one agent to one another agent, and they talk through to one another via a JSON RPC. Right, as you can see from here. If I go to the view card, you can see it here, and there's a command here. So there is something they called a well-known. So there is a dot well-known. I think it's well-known. Right, and then I think it's JSON. This is it, right? So this is how most of these things are going to be, right? That's where you're going to find most of this information. This is actually the same information you're finding here. So if I go to the official website, they give something they call agent discovery with some information about it. There is also something they call what is it? Yeah, so these are the main concepts around it, right? So you can, if you get time, you can just check it out. So thank you for watching this tutorial. See you another time. Stay blessed. Bye. Yeah, this is what I mean, right? So the one I spelled was wrong. So this is the agent JSON which you have, and then this is where the LLMs will check to see what they're supposed to do. You can see the name of it, the description, the capabilities, and then the skills and what it's supposed to do, what it's supposed to take as input, and then the output, and then some descriptions. All right, and then this is a simple UI to make it beautiful. But the actual one is here. So well-known dot well-known and an agent, and this file has these instructions so that one agent can talk to one agent, get that information, and know what to do. Right, perfect. So thank you. See you another time. Stay blessed.